Mechanical components create mechanisms that generate force and movement within a product. They can be small and precise as in a watch, or large and powerful as in a crane. All mechanical systems have mechanisms that transform an input motion into an output motion. Mechanisms are designed so that you can gain advantage from using them, making it easier for you to do a task, and some mechanisms can even change one type of motion into another. Linear motion is a movement one way in a straight line, for example, a sliding door, and rotary motion is moving in a circle, for example, a helicopter blade. Reciprocating motion is movement backwards and forwards, as in a jigsaw or piston, and oscillating motion is swinging in alternative directions, for example, a pendulum in a grandfather clock.
Nearly all mechanisms consist of combinations of basic components and can include pneumatics and hydraulics. The basic components include lever, linkages, pulleys, chain and sprockets, gears, cams and cranks. Mechanisms can help move heavy loads by amplifying a smaller force. A lever pivots around a fixed point, which is also known as a fulcrum or pivot. Look at the hand tools in the workshop. Many of them are designed on a lever principle and can be used to increase force. An example of this is a pair of scissors which work by two levers, the blades pivoting around the fixed point at the base of the handle. Linkages connect different parts of a mechanism together and are used to transfer motion. Simple linkages often use levers to change direction or to multiply force.
Think about lifting a heavy rock. What if you had to lift it on your own? Using a pulley system allows you to lift a heavy load using a system of cables, ropes, and pulleys to lift heavy weights, making them feel lighter than they really are. Do you remember learning how to ride a bike? A bicycle is a great example of a chain and sprocket mechanism, which works in the same way as a pulley system. They transfer movement, but with less risk of slippage. Most GCSE students aren't old enough to drive yet, but you can dream of gears. Gears are the wheels with teeth cut into their outer edge, and a gear train is when two or more gears are meshed together. Some gears can change the type of direction or motion. Rack and pinion gears are used to turn rotary motion into linear motion.
A worm drive and a worm wheel changes the direction of rotation by 90 degrees, as the worm drive only has one tooth and will turn much faster than the worm wheel. This method is used to tune guitar strings. Bevel gears change the direction of the rotation by 90 degrees as the teeth on the wheels are each dangled at 45 degrees, so the gears mesh at right angles. The last type of mechanism to look at is cams and cranks. Cams are wheels which have a shaped profile. A follower runs around the edge of the cam and makes a reciprocating motion. The motion can be changed by using a different shaped cam. Cranks are the shafts that are stepped along the lengths of the cams by connecting a rod, and a rotary motion will be produced by a reciprocating motion. This motion can work in reverse if it is driven by a piston.
Pneumatics, the use of compressed air and hydraulics, the use of compressed fluid are technologies that are often used with mechanical systems. Pneumatic systems use the potential energy stored in its compressed air by controlling the release of the air. The energy can be turned into movement. An example of this is a dentist drill, which is lighter and faster than an electric drill. Hydraulics involves forcing a fluid through a small cylinder into a large cylinder, which increases the output force. Combining this with levers creates a very capable machine, which is often used on the arms of mechanical diggers.